The mathematician is Italian. The phone figures all that stuff out. I thought I was going to say something, but now I can't remember what it was. It doesn't matter. I can edit this out later. Hey, should we do another giveaway? Good afternoon, good morning, good evening, good night, good whatever time it is where you are. Welcome to Thursday or Friday's Math Minute. The only Math Minute guaranteed to be on a Thursday or a Friday and guaranteed to be no more than 10 minutes long. Throwing it back today. Not messing about with the computer at all. Not doing anything there. We got the iPad in front of me. It's not cooperating, of course. Yeah, we're just going to do some math, I think. By popular demand. This has been surprising to me, but my absolute most watched videos so far, the videos that you, the people, are demanding, are about function notation. So we're going to do some more function notation today. We're going to look at function notation, which you'll recall from a previous video, I'm sure, has something to do with this weird f parentheses x expression. But we're going to look at function notation and trigonometric functions. Because in addition to having done previous videos on function notation, I have also previously done videos on the trigonometric functions and trigonometric identities, specifically writing things down like sin² theta plus cosine squared, that's not a 2, cosine squared theta equals 1. And I get questions from students when we look at this one-on-one. They're like, why do they put the 2 there? If we're saying, like, why are we saying cosine squared theta? Are we squaring just this symbol, cos? Are we multiplying by the theta? What's going on here? And it's a good question because it definitely looks weird at first, particularly if you're not familiar with the ins and outs of function notation. So just as a reminder in this whole process, originally you start out, let's just take multiplication as an example, writing things like 3 times 4. This is very satisfying. And no one has any problem with this. But then a mathematician comes along and they say, no, we are going to start replacing these numbers with symbols because we want them to stand for unknown quantities. And so we want you to write 3 times n. And you say to yourself, well, okay, whatever, I guess I'll write 3 times n. But then the mathematician is like, no, you can't use the x. The mathematician is Italian. You can't use the x. You can't use the cross symbol. It looks like an x. And you think to yourself, gosh, I don't see why not. I mean, it's an awfully small x, but okay. What do you want me to use instead? And the mathematician is like, nothing. Just write 3n. And so then we get used to this and we think, okay, so when we set stuff next to each other, that means multiplication. Fine, whatever, mathematician. This is the way you wanted it. And then it's like, well, what if we actually want to do the multiplication? What if n is equal to 4? Are we supposed to write 3, 4? And of course the mathematician is like, no, because now that looks like 34. Mathematician's not Italian anymore, just a regular guy. Mathematician says, no. To represent the multiplication, you're just going to use these parentheses instead. And so now 3 parentheses 4 means 3 times 4. And that's what 12 is. That's like, okay, whatever. So now parentheses mean multiplication. And then the mathematician comes along later and he writes down this. And so you, having been trained by the mathematician to interpret parentheses as multiplication, think, okay, so we have 2 variables here, right? We've got f and we've got x, and this means f times x. And the mathematician is like, no. This is a totally different thing called a function. And you're like, what? Why isn't this just f times x? You just trained me to treat parentheses as if it's multiplication, and now you're telling me I can't do that anymore. And the mathematician is like, yeah, that's exactly what we're saying. So if you have looked at the previous videos, you know that when we see this particular use of parentheses, this does not mean some variable f times some variable. Oh, I should do the card. So I'll put the little card up here. You can check back on that previous function notation video. If you have seen it, you know this does not mean some variable f times some variable x. It means there is some rule we're going to apply to an input that we call x. So the x here is the input to some function or rule. We're going to apply a rule to that function and we're going to produce an output. And the f of x itself is what we call the output. F of x in that case, we pronounce f of x, and what we really mean is there is some function of x. There is some rule or otherwise index, some table of values that is relating inputs to outputs in a particular way. So that's what f of x means, right? How does this relate to trigonometry, right? What do we do with the trigonometric functions? Well, the first thing to recognize is that when we write something like sine of x, that's how we say that. This is not sine times x or cosine of x. It's not that sine or cosine, S-I-N-C-O-S, are symbols that are standing for some values and we're going to multiply by x. Instead, sine and cosine are rules that take an input x, that input is usually an angle, and produce an output. Typically we think of as some kind of ratio, although, as I have also covered in a previous video, it's better to think of as some kind of x or y coordinate on the unit circle. So just to take sine, for example, if x, again, is some kind of angle measurement, I'm going to do my angles here in radians. If you don't know what radians are, I'll do a future math minute on that. I'm sure you can also look it up. And y here, the output, is going to be some kind of ratio, or specifically, it's the y coordinate from the unit circle. And so for something like, say, negative pi over 2, sine is going to produce negative 1 as the output there. We're taking the input negative pi over 2, producing the output negative 1. For an input of 0, sine returns an output of 0. For an input of pi over 2, sine returns an output of positive 1. For cosine, we can do exactly the same thing. X, again, is going to stand for an angle. Y, in this particular case, is going to stand for the x coordinate from the unit circle. So again, cosine is our x coordinate, sine is our y coordinate on the unit circle. X, again, is going to be an angle of some kind. In this case, we might have input-output pairs like 0 paired with 1. When you input 0 to cosine, you get back 1. Or pi over 2 produces an output of 0. Pi produces an output of negative 1, and so on. So sine and cosine are both examples of function notation. But instead of just using the generic rule f, we specifically use this particular label, sine or cosine, depending on what it is. These rules basically get used so often that we give them special names that we want to remember always and that we want to stand for the same thing always. Whereas like f of x is just very generic. F of x stands for anything. When you start in algebra, f of x is 2x plus 3, but it's also half of x minus 8. Or it's x squared minus 7x plus 10 or something. F of x is just kind of a generic rule that stands for anything we want in any given scenario. Sine of x and cosine of x are specific rules that we reuse over and over again, and so we assign them special names and leave them in function notation all the time. One thing we can use that function notation for is inverses, right? So sometimes we'll talk about some f of x and its inverse. But mathematicians, as always, don't like to write down words, they like to write down symbols. And so they'll talk about f of x and f inverse of x. Almost looks like what's going on there is we're raising something to a power of negative 1. But again, we let these symbols represent something else. This is notation, this is not mathematical. We are not taking the reciprocal of f. We're not raising f to the negative 1 power, we are inverting f. Specifically what that means is we're switching our x and our y coordinates. And so if you're in trigonometry, you have probably worked with inverse sine and inverse cosine. So inverse sine and inverse cosine take as inputs what was the output of the sine function or the cosine function, and then give as outputs what was the input to the sine function or the cosine function. In other words, this time it's our y value that's going to be the angle, because in both cases for sine and cosine up here, you can see that the x coordinate was the angle, the input was the angle. And now that means that our input, the x variable, is going to be what was the output over here for sine. So that is the y coordinate from the unit circle for sine and the x coordinate from the unit circle for cosine. And so, of course, what this ends up looking like is that what was an output over here, negative 1, 0, and 1, now becomes our inputs, and what was the input over here for sine now becomes our series of outputs, negative pi over 2, 0, and pi over 2. Or for cosine, same thing. What was an output over here is now an input, 1, 0, and negative 1, and what was the input over here, the angle measure in radians, now becomes the output, 0, pi over 2, and pi. So that's one use of function notation with trigonometric functions. The other use, the one that came up in that other video I did earlier, is when we write things down like sin² theta plus cosine² theta equals 1. So here's what's going on when we write this down. There was actually another video I did. Maybe I'll just link these in the descriptions. I can't do cards for every single one of them. I guess I could, but I'm lazy. I'm probably not going to. In this other video, I looked at function notation and how it ends up relating to the distributive property. And I gave a challenge at the end of that where in some cases we would end up multiplying function values together, multiplying outputs together. So let's think about that for a second. Let's say we had some f of x, which remember means the output when your input is x. And we wanted to multiply it by itself, right? By that same f of x, that same output when the input is x. We could write this long ways every time, but as is typically the case for mathematicians, we want to shorten things up. And so we're going to write f² of x instead. And this just indicates we are multiplying that output by itself twice. In fact, you can probably anticipate the extensions available here. If we did this times itself 3 times, we would write f to the 3rd power of x, or f³ of x. We can do precisely the same thing no matter what the function is. Obviously, it works for something like f, our generic function, but it could just as easily work for sine or cosine, right? So when we write down sine of x times itself, which we know ends up being important for the trigonometric functions because of their connection to right triangles and Pythagorean theorem, we're just going to write this down in function notation as sin² of x, or cosine x times cosine x. We express as cosine² of x. But again, eventually we keep shortening these symbols and we write them a little bit differently. We might use different inputs, theta rather than x. And as long as the theta is there, we don't typically also use the parentheses, although we definitely could. I don't really know. I don't know if the parentheses make it more likely that we're going to confuse this with multiplication or less likely, but that's what's going on there. That's why you see these weird kinds of expressions like sine to the 2nd power of x or of theta, or just sine x, sine of x. We're not multiplying. Sine is not some set of symbols that actually stand for a certain value that we are then multiplying by the input x. It is in fact a special rule. We give it a special name. We use that name all the time. And then we kind of extend the different things we can do with that name, whether it be raising it to certain powers if we're going to use those output values over and over again, or making something look like we're raising it to a power, but actually trying to symbolize the inverse of the function, as it does come up quite often. So there you have it. That is what's going on with your cosine² and your sine², and some other weird function values that pop up occasionally. I said at the beginning of this video, I teased. That's a tease. That's what we in the business call a tease. I'm going to do some kind of giveaway because, my students demanded it. What do I want to give away? In the last video, I suggested I give away this amazing Apple Pencil box. And this time I will say, it could come with an Apple Pencil, but you can see, I don't know if you can see that there. There's something wrong with that Apple Pencil. The thing that's wrong with it is that a 7-year-old played with it and broke it. I'm not going to say what 7-year-old, but some 7-year-old out there in the world. You know who you are. He played with it and he broke it. But in any case, maybe a giveaway. Comment down below. Do you want me to do a giveaway or not? If you want me to do a giveaway, what should I give away? I have other boxes.